Good morning, friends. It gives me immense pleasure to be here for my course Flight Mechanics. As of now, I have already completed my 3 courses. First one is Engineering Thermodynamics, Aircraft Systems, and Aircraft Stability and Control. These 3 courses I have already completed, and these all are available in YouTube channel of IARE. Now I have started the course Flight Mechanics. In this, I have already completed 4 classes. This is the 5th class, and hope this will be quite sufficient and quite interesting. My today's topic is aircraft design, phases and types. This is the topic for my today's class. So, as you know, I am Dr. Yagya Dutta Dwivedhi, professor from IARE Hyderabad, from Department of Aeronautical Engineering. And in today's class, we are going to discuss about design, aircraft design performance, phases of design, introduction to atmosphere. Let's see how much we are able to do this. So, first thing is the design. So, what is the design? So, this we can see here that the definition of the design. A design is a plan or specification for the construction of an object or system or for the implementation of an activity or process or the result of that plan or specification in the form of a prototype, product or processes. So, the design means it is a plan or specific. We have to plan it out and give some dimensions. How much size, how much this thing, and how to make it, and how to implement this plan which we have done it. And also, what are the specification of this, your product, these all things, and how to make the product prototype, and so on. The main aspects of aircraft designs are aerodynamics, propulsion, controls, mass, structures. These are the 5 items which we have to see as a designer of aeronautics. Aerodynamics is very important. Aerodynamics means it is the branch in which the lift and drag and other aerodynamics flow of the air is related with the aircraft, that is to be handled. Propulsion means it deals with the engine, where the locomotion is done by some help of the equipments. Those equipments are important and they are responsible to give the locomotion of the aircraft. Controls means the aircraft should go to the desired direction. Wherever the pilot wants, as per that, it can move from one place to another. And also the mass, the weight of the aircraft is very important. How much should be weight? And the structural rigidity, the strength of the structure is very, very important. The aircraft should be able to sustain in a given amount of forces and different types of loading and all, it should be able to sustain. So all aircraft designs involve compromises of these factors to achieve the design mission. All aircraft designs involve compromises of these factors to achieve the design missions. Now, design phases. What are the design phases that we will be observing here? The design of any aircraft starts out in the 3 phases. There are 3 different phases of design. So, these are the 3 phases. So, first one is the conceptual design. So, in this aircraft, conceptual design involves sketching. So, first you have to make the diagram that how should be the body, how should be the tail, how should be the wing, this is the wing, this is the tail, this is the vertical fin, this is the pilot, this is the cockpit. So, first we have to draw the sketch, a variety of possible configuration. It is not only one, you can make wing up, you can make wing here, tail you can make here, as a canard, different types of configuration you have to make it that meets the required design specification. So this sketch should be as per the design requirement, which your customer will give the specification, what type of aircraft he want or the company want. Accordingly, you have to design the specific, sketch your diagram, and different possible configuration you have to specify. This is called the conceptual design. By drawing a set of configuration, designers seek to reach the design configuration. So by that, designer will try to reach to the specific configuration that satisfactorily meets all requirements, as well as go hand in hand with factors such as aerodynamics, propulsion, flight performance, structures, and the control of the system. So this sketch which you have made, this should be validated by the help of the theory like aerodynamics, your propulsion, flight performance, structural, and the control system. So these parameters you have to see. Accordingly, you have to draft your design figure, and then only you should try to develop the things. Now we should have for this conceptual design, there are the 7 points which we have to observe, and these are here mentioned in this. The 7 intellectual pivot points for conceptual designs. First one is the requirements. So I have given just before the lecture, before this lecture, I gave another that requirements of your airplane requirements. So in that range, endurance, climb, your service ceiling, self ceiling, cost, maintainability, reliability, maneuverability, all the parameters which we have discussed in my previous class just now before this. So in this, first we have to see the requirement of the aircraft, what the customer want, which type of aircraft we have to make. Then we have to see the weight of the airplane. First estimate, we have to calculate how much will be the wing, how much will be the fuselage, how much will be tail, how much will be the engine, all the components we have to first estimate. Then critical performance parameter is maximum lift coefficient, how much this aircraft can generate the CL maximum. Then lift to drag ratio L by D, wing loading W by S, and thrust to weight ratio T by W. These are the very, very important parameters that we have to see, that whether these things we are able to achieve as per the requirement or not. Then we have to see that configuration layout, shape and the size of the airplane on a drawing for a computer screen. Then better weight estimate. So we have to see that weight is estimated. Then performance analysis, does the design meet or exceed the requirement? If yes, then you go for optimization further, it is the best design or not. If it is no, you have to again go to this critical performance, you have to change it as per the requirement, and again you redo, and you try till the time you are not getting the correct requirement. These 7 intellectual pivot points for conceptual design. So if you want to do the conceptual design, you have to follow each and every step, then you have to proceed ahead. Now we will see the next level. It is the preliminary design phase. That is the second phase of the design. The design configuration arrived at in the conceptual design phase is then tweaked and remodeled to fit into the design parameter. So whatever we have done in the conceptual phase, so the design configuration arrives at the conceptual phase, which we have already understood. Then we have to remodel it to fit the design parameter. In this phase, wind tunnel testing and computational fluid dynamics calculations of the flow around the aircraft has to be performed. So they are called the preliminary design phase. Third one is the major structural and the control analysis is also carried out in this phase. Aerodynamic flaws and structural instability, if any, are corrected and the final design is drawn and finalized. So aerodynamic flaws and structural instability, if any, are corrected and the final design is drawn and finalized. So this is the preliminary design phase. Now detailed design phase. So we have done the conceptual design phase, then preliminary design phase. Now the detailed design means we have to each and every component, their size, where the nut, bolt, rivets, all the things we have to see in the detailed design phase. In this phase simply deals with the fabrication aspect of the aircraft to be manufactured. It determines the number of design and the location of ribs, spar, section and other structural elements. So in this detailed design is for the fabrication or manufacturing aspects. Means how your ribs should be there, how the spars should be there. These all things, all the nut bolts, small things, we have to make a separate design. We have to make sure that whether we are able to fabricate or not. So that thing we have to see. All aerodynamic, structural, propulsion, control and the performance aspects have already been covered in the preliminary design phase and only the manufacturing remains. So up to flight simulators for aircrafts are also developed. So in this, manufacturing and the flight simulator also to be developed for this in this detailed design concept. Next is very important thing is the aircraft sizing. How we can make aircraft big or small as per the requirement. So we have seen the conceptual design. In the conceptual design, we will make in the sketch in a paper or your computer what will be the size of the wing, what will be the size of the fuselage, what is the size of the tail, and what is the size of the vertical fin, fuselage, your seat arrangement, your engine location, your aesthetic of the aircraft has to be assessed. The wing will be in the upper, middle or the lower. Your tail will be the T-tail or the crucified tail or the horizontal tail in the same area. It will be the single vertical stabilizer, double vertical stabilizer or triple vertical stabilizer. Different configuration as per the requirement of the customer we have to finalize. This is in the conceptual phase. Then we will go for the preliminary design. In this, we will do the wind tunnel testing of the model. Then we will see the computational fluid dynamics, whether it is meeting our requirement or not. Okay. Then in the last one, which we have seen in a detailed design, the manufacturing part, whether we should manufacture this component or we are able to do this thing. Then we have to make the simulator and we will see that it is in the same way or not. These all things are performed in the design. But if you see about the sizing, so how the sizing of the aircraft is done. So the sizing we can divide into the 4 groups. So if you can see here that here fuselage and the electrical power system in this one group. Another we have the performance, propulsion and the wing here. Another we have the structure and the fuel system. Another we have the stability and the control, actuation system and the aerodynamics. These all parts in the 4 groups we have divided, and for each part what the size will be there. Propulsion means engine, wing, engine and how much it is performing. Your structural and the fuel system is to be accommodated. Stability and the control has to be assessed. Actuation system has to be checked that what type of actuation of the flight control systems and what is the behavior your aircraft is behaving aerodynamically. So if you can see, one part is here, structure is also important, propulsion is also very important, performance is also very important, stability and the control is also, all are very, very important. Fuselage. So what is the power required? All things you have to see that what will be the size of the aircraft. And this size has to meet with the weight requirement. Otherwise, if the weight is increased, you cannot fly the aircraft. So we have to make sure that we have to size the aircraft where the weight is in the given limit and everything is accommodated on the required space. That is the objective of the aircraft sizing. Now we have to do the design optimization. So how to go about this design optimization is, first is the requirement, performance requirements, what are the requirements. Then we will go to the conceptual design, that is the first phase. In this, will it work? We have to ask some questions. Will it work or not? What does it look like? How it is looking? What requirements drive the design? What trade-off should be considered? What should it weigh and the cost? So this preliminary design freezes the configuration, develop the lofting, develop test and analytical base, design measure items, develop actual cost estimate. Now the detailed design, we have to see that design the actual pieces to be built, design the tooling and the fabrication process, test measure items, structures, landing gears, finalize weight and the performance estimate. So in the detailed design, we have to see these all things. In the preliminary design, we have to see these all things. In the conceptual design, we have to see these all things. And after that, when these all things are done, then you have to go for the fabrication. Then you have to go for the fabrication of the aircraft. So these are the design optimization, and one by one we have to proceed ahead to achieve the goal. So now the difference between conceptual, preliminary and the detailed design, just by this diagram you can find out that what is the difference. So this is a schematic illustration of the difference between conceptual, preliminary and the detailed design. So if you see here is a fuzzy configuration definition. It is just a rough sketch. Here product of the conceptual design, it is like this. Then product of the preliminary design, if you see, it is not looking somewhat, it is approximately same, but it is this model which we have done, we have to see in a wind tunnel. We have to simulate in the CFD whether this is able to produce the given requirement or not. And if you see about the third one, it is the detailed design. For every nut, bolt, for every item, their size, everything we have to see here. That is the difference. A simple one difference is given here. In this way, there are thousands of difference are there between each design. But here only one thing, it is shown that in a wing, if you see in this, only a drawing is here. This is, we have to simulate in a wind tunnel experimentally or with the help of CFD or by both. And after this, we have to see that if we are putting some nut bolts, screw on the wing, what the effect we are going to face. That is the detailed design of this thing and how we can optimize this size of this each item. So this is the difference between conceptual, preliminary and the detailed design of the aircraft. These are the references which I am taking: Anderson JD Jr., Aircraft Performance and the Design, International Edition, McGraw-Hill's first edition, 1999, SL by Aircraft Performance Theory and Practice, AIA Education Series, AIAA. Any questions you are welcome to ask. And thank you very much for the joining. Please also, I request you to like and subscribe this video. If any queries, you are welcome to ask. I will try to reply. My email is ydwvedhi@gmail.com. So you are always welcome to us. If any where you have some doubt or I have done some mistake, that is also welcome to clarify, and I will try to see if it is wrong. I will try to rectify. Thank you very much for the joining. And please be tuned for my next lecture.
Like, share and subscribe. Hit the bell icon for more updates.